Good morning. What I want to look at today is the rate of decay and half-life. And you'll find this on page 414 to 416 in your book. So let's have a look at these two terms. The first one I'm going to look at is this thing called rate of decay. And as far as you're concerned, rate will always mean compared to time. And you have met it before, like acceleration is the rate of change of velocity. So you've met it before, and velocity is acceleration is the change in velocity over time taken. So you've heard of this term rate before. Now the thing about decay is the nuclei, the radioactive nuclei, become less with time. They change, but they do not disappear. So let's just write that down. They don't disappear. And we'll see from the last day's video where you have uranium 238, 92, and it decays. It doesn't disappear. It emits an alpha particle because it's unstable. And it's unstable because it hasn't got the same number of protons as neutrons. Remember, the 238 is the number of nucleons. So it has more neutrons than protons, so it's unstable. So it becomes thorium because it emits an alpha particle to become more stable. And again, there's your 90, and 90 and 2 gives me 92. So that has to be 234 because 4 and 234 gives me 238. So this radioactive nucleus has changed to thorium and emitted an alpha particle. So it has changed, it hasn't disappeared. So that's the first thing. The decay, the nuclei do not disappear, they change. So they get less with time. Get less with time. There are less nuclei with time. And the decay depends upon the number of nuclei present. In other words, the greater the number of nuclei, the greater the decay. The less the number of nuclei, the less decay. And this was investigated by that French man called Henri Becquerel. And he gave his name to the unit in which radioactivity is measured. So the rate of decay depends upon the number of nuclei that are there. It also depends on the type of nuclei that are there. And the rate of decay is measured in becquerels after Henri Becquerel. Now this half-life always poses a bit of a problem. But again, if you look at page 414, you will see that the definition is the time taken for half the initial nuclei to decay. That's the definition, and you're going to be asked that in exams, so you better know that. It also talks about half the activity to fall by half. They're both the same thing because the activity and the nuclei are related. They are directly proportional. So we're going to look at a graph. I'm going to look at this graph here. And it's a very important graph because it's usually got activity. Now it's the same as the graph that you have on page 415. So I'm going to change it slightly. I'm going to put the activity in becquerels. And you see the way it starts up here. It starts up and it's a curve. It's known as an exponential decay curve. And it skids along, it's asymptotic along the x-axis. So it's known as an exponential decay curve, and it's asymptotic along the x-axis, and it starts at a particular value on the y-axis. And if you want to get the half-life, well, you can read it off the graph. Now if you look at the one on page 415, it starts at 1800. Well, if you go down to 900, which is about there, but you should be doing this with a ruler and a pencil. You go across, we'll say that's 1800. And that's now 900. That's half the activity. See that? Half the activity. You go across and you read down onto the time axis, and that's known as your half-life. T subscript a half. T subscript a half is the term known for half-life. See that? There's it there. So you want 2 half-lives, you go to 450 becquerel, and you come down there, that'll be 2 half-lives. And likewise, well, 450 divided by 2 is 225. I better write that in, 225. That's going to give you 3 half-lives. And you read that off using a ruler. Fair enough? Now, how do you work out the half-life and things like that? Well, the best thing to do is to draw a table. And I'm going to show you what you put in the table. And the table is useful and you can go 2 ways with it. So you just have a look at this table. So I'm going to put in here activity. Now you'll see that I'm going to go up here in a wee minute. But I'm going to go down for start. Activity measured in becquerel. Right? So saying it starts off at 1224 becquerel. Right? And over here I'm going to give it a half-life of 3 days. Remember that the half-life depends upon the nuclei itself. And we're going to have the amount left, and then we're going to have amount decayed. Right on the edge there now. So the half-life, I'm just going to have this. So it's 512, 256, 128, 64, 32, 16. Get the general gist, right? So I'm going to say that's day 0. So day 0, there's 1 and there's none decayed. After 1 half-life, so that'll be 3 days. Right, I can put in, I'll just put in a column here of half-lives. I'll just there, right? No half-lives. 1 half-life. 3 days. There's half of it left, and half of it has decayed. Now notice, the half and the half gives you 1. There's still the same number of nuclei there, but they have changed. So after 2 half-lives, and that'll be 6 days, there'll be a quarter of it left, and there'll be 3/4 of it have decayed. After 3 half-lives, which is 9 days, there'll be 1/8 of it left, and there'll be 7/8 of it decayed. After 4 half-lives, which is 12 days, there'll be 1/16. Now notice, look, we're halving this each time. Half of it is a half of that is a quarter, half of that is 1/8, half of that is a 16th. And notice on the other side, that and that gives you 1. That, please move, you brute you. That and that gives you 1. Add them, look, 3/4 and a quarter gives you 1. 7/8 and 1/8 gives you 1. Yes? So we'll not go down any further than 15. That's 5 half-lives. I'll have a 32th and 31 32ths. Fair enough? Now I also know the digital ones of these, because being examiners that can be slippy. So that's 1, 0.5, 0.25, 0. Hang on to see, 0.125 and 0.125 divided by 2. Turned on 0.125 divided by 2. You get 0.0625. So know the digital ones of those as well. Now sometimes they ask you to go back in time. So they might ask you, when was that? How long ago was that an activity of? They'll say, let me just see. When was that an activity of 16,384? How far back in time? So let's double this. 2048. So I have doubled that to double it. 4096, 8192, and double up to that. Now, go back in time. That was the 3 days, 6 days, 9 days, 12 days prior to that. That was the reading. So sometimes they ask you to go back in time. See that? I'm going back in time. What was that activity 12 days prior? So I've done the table, only this time I've went back in time. Fair enough? And that's more or less it. So there will be a test on this as well, so be prepared. And do know that these tests are all now time bound. I want them done on time. Thanks very much. I'll see you later.